Hello, thank you for joining us today. I'm Yuri Dukovny, Solutions Architect with AWS, and I have Lior with me today. Lior, could you please introduce yourself?
Yes, thank you everyone for joining. I'm Lior Polak, a Solution Architect specializing in security and identity.
Thank you, Lior. What will we be talking about today?
Today we'll talk about the ways you can integrate your workforce identities with AWS.
While you are mentioning workforce identities, what do you mean?
So companies typically have two types of identities to deal with. The first one is employees and contractors who make up their workforce. These workforce members need access to their AWS accounts, and they may also need to gain access to a diverse number of business applications. Companies use a workforce identity system such as Okta or Azure AD for this purpose. And today, we will focus on this use case, where we want to provide federated access to AWS accounts and business applications. The other type of identities companies typically have is users of customer-facing applications, such as users of a retail storefront. AWS has solutions in this space, such as Amazon Cognito, but we will keep this out of scope for this session today.
Okay, now what we understand the use case, let's brief talk about AWS SSO.
Sure, Yuri. AWS SSO makes it easy to centrally manage access to multiple AWS accounts and business applications, as well as provide users with a single sign-on access to all their assigned AWS accounts and applications from one place. And now you can integrate and authenticate your existing identities from external identity providers or IDPs such as Azure Active Directory through the support of Federation with Security Assertion Markup Language or SAML 2.0 standard. You can also provision Azure AD users and groups into AWS SSO automatically with the open standard of System for Cross-Domain Identity Management or SCIM. The latter makes it easier for you to grant access based on existing users and groups, seamlessly integrating with multiple AWS accounts, and provide your users the convenience of the sign-in experience they know with single-click access to assigned AWS accounts and applications.
Sounds great. So the question we are addressing today is about AWS multi-account access and governance, and about simplifying it for users and administrators using existing Azure AD identities.
Yes, but before that, let's take a step back and provide an overview of the mechanisms in place to control access to AWS accounts.
That would be great. Let's talk about IAM.
With my pleasure. So IAM, or Identity and Access Management, is a very special AWS service. 100% of AWS customers are using IAM. If you do anything on AWS, even if you access from the web console, you call an API endpoint, and you're getting authenticated and authorized to call this endpoint with IAM. The I in IAM stands for identity, the human or application calling the AWS endpoint. We also call this the principal. And the AM stands for Access Management, a powerful, flexible permission language for controlling access.
Okay, although we will focus on human workforce identity for most of this webinar, we will touch briefly on how IAM helps with human and machine identity.
AWS supports several identity authentication modules with IAM. First, you can create individual IAM users, assign them to groups, and attach permission policies.
While this is the simplest way to grant access, there are some challenges, right?
Yes, indeed. There are two key challenges. IAM users exist in a single account, and you don't want all these unsynchronized separate identities. Second, users will potentially be using long-term credentials stored in their user or application environments. And to avoid a security risk, it will require additional measures to ensure users rotate their credentials periodically.
So what you imply, while this is meant for workforce identity, it's sometimes used as a simple way to grant application access.
This is why we recommend that whenever possible, applications calling AWS endpoints should use IAM roles and attach them to AWS services such as EC2, Lambda, and so on. These IAM roles provide a temporary set of credentials, which AWS manages for the application. You can define how long these credentials are good for, and AWS will rotate them before they expire. Customer applications can access these credentials, most commonly by using the AWS SDKs or CLI tools.
Okay, coming back to human identities, you can also create IAM roles that can be assumed by users. This IAM model is called IAM Federation. In this situation, a company administers the workforce identities in an identity provider that supports the security assertion markup language standard, also called SAML, or the OpenID Connect standard, also called OIDC. They use one of the standards to connect the identities into an AWS account, right?
Correct. And every time they log in, they're getting what's called an IAM session. From that session, they can assume a role. The session operates within the access policies attached to that assumed role. So, what is a policy?
Okay, a policy is one of the key concepts of IAM, and it's been used to provide authorization. We can say that there are two essential parts that take place with policies. The first one is the IAM administrator defines what actions are allowed or denied for resources in the policy. The second one is on AWS to evaluate policies on each and every request to access these AWS resources. When you define your access policies, you attach them to a principal. A principal is a user group or role, and the policy then specifies which action the principal can perform on your AWS resources and under which conditions.
Another type of policy that you need to understand is the trust policy of roles. Because roles are first assumed and only then can be used to access resources which are allowed in the access policies that we attach to them, the trust policy is where you authorize who can assume that role.
Let's see how policy is composed. IAM policies operate in what we call the PARC model. Principal, who is doing the action. This can be a user, a role, or AWS service, such as Lambda or EC2 instance, for example. Action, what the principal is allowed or denied to do. Resource, on what resource the action can operate. And condition, when to allow and when to deny an action based on conditions and context.
When using identities from an identity provider through AWS IAM Federation, we first have to configure SAML or OIDC Federation, and then we need to create roles that trust the federation provider in AWS Accounts and attach some access policies to the role. We will see how that's done momentarily. Importantly, when you use IAM Federation, AWS trusts whatever your external identity provider claims about your identities. That is, after the user signs into the identity provider, the identity provider sends IAM some assertions about the user. IAM looks at the assertions for information about which roles the user can assume. The identity provider specifies which roles can be used by providing one or more Amazon resource names, also called ARN, for each role. These ARNs are unique identifiers for these roles. If a user has access to multiple roles, the identity provider passes an ARN for each role. When this happens, IAM prompts the user to choose the role they want to assume.
So the IDP needs to be aware of the roles in AWS accounts in order for identity administrators to be able to associate them with users and groups, right?
Correct. That means that administrators have to implement some kind of role query against IAM and configure that into their IDPs.
Let's look at user experience for this scenario. User can start from accessing AWS console and then will be redirected to the IDP. This is called service provider or SP initiated login because AWS console plays this service provider role here. Or user can start from the identity provider portal, provide credentials there, and then choose an application he'd like to single sign on to. In our case, it's the AWS console application. This is called IDP initiated single sign-on scenario. In both cases, the IDP provides an assertion that contains information about user identity and roles this user can sign in with the service provider.
So let's see this in the demo. For example, what should the administrator do to integrate an existing Azure AD directory with a brand new AWS account?
Yeah, that would be great. Let's do that.
We're starting from Azure Active Directory. I already have some users and groups created here. The next thing to do is to create an enterprise application. I already have 2 accounts that I've set up in advance, and now I need to create the third one. I'm going to select New Application, and I'm going to search the gallery for the AWS application. Let's give it a meaningful name.
The user will see this name on the user's portal when he's going to single sign on to the account, right?
Correct. And this is why we have to give a name that the user can identify. Next, let's select Setup Single Sign-On and SAML. I don't want to save the settings yet, and I'm going to edit the basic SAML configuration and modify the identifier. The reason is that we already have 2 accounts set up, and we need to give each and every one of them a different identifier. So because this is the 3rd account that I'm adding, I'm just going to add #3 and save this configuration. Okay, the next thing I need to do is to download the Federation metadata XML file.
And I assume we will upload this metadata file later to AWS IAM when we will configure a SAML identity provider.
Yes, in fact, we're going to do this just now. So I'm in my AWS account that I want to add to the Federation with IAM, and I'm going to the IAM as a console and to identity providers. I'm going to create a new provider and choose this provider type as SAML. I will give it a meaningful name like Azure AD and upload the metadata file that I just downloaded and just finish the configuration, create it. Next, I will create 2 roles, and these roles will be used to assign users from Azure AD later on. So I'm going to create a network administrator role and a support user role. And one important thing to remember is that you have to select the type of the trusted entity to be your SAML Federation provider. So I'm going to select SAML 2.0 Federation and use SAML provider as Azure AD. I'm going to allow both programmatic access and AWS Management Console access. And here I'm going to assign some policy to my role. I'm going to use the job function manage policy type.
And we are choosing AWS Manage Policies for this demo. Also, customers may always create their own policies and customize permissions with the full power of AWS IAM.
Correct. I'm using the AWS job function policies because it's the easiest way to start. It gives you same defaults and you can customize them later. I'm going to skip tag creation and give the role a name like support user role and create it. Next, I'll create another role with the same configuration. So SAML 2.0 Federation, same provider, same settings, just with a different name and policy. Here I'm going to use the network admin policy. And create. The next thing we need to do is to create a user that will give to Azure AD so it can pull the roles and then assign them to our users.
And this will be the read-only user, correct?
Yes, we'll start by creating the policy. Let's see how we do this to minimize the access that this user will have. So I'm going to select the service as IAM and the action to be just list roles. This will be the only action that will be permitted for this user. Let's review it and give it a name like list roles and create the policy. Now let's create the user and assign the policy. I'm going to choose access type as programmatic access, and I'm going to attach the policy that I've just created. Now let's see how we set up provisioning in the Azure AD side. So I'm heading back to Azure and selecting provisioning menu item, and I'm going to change the mode of provisioning from manual to automatic. Next, I will have to put in my user credentials in this dialog. So I'm heading back to AWS. I'll copy the access key ID and put it in the client secret box. Then I'm going to use my secret access key from AWS and put it in the secret token box in Azure.
And there is a little bit different terminology here between AWS IAM and Azure AD.
Yes, this is something to remember. Next, I'm going to test my connection, and then I can click Save. Now, once that's set up, we can go ahead and enable provisioning. I'll click on and save the configuration again. Now my provisioning has started, and I'll refresh to see if it finished already. So I can see that I got 2 roles synchronized from AWS, and my initial sync was completed. Now, one thing to remember is that the initial sync is taking place almost immediately, but follow-up sync will be done on intervals of 40 minutes. So every change you make in AWS will only be synced here once every 40 minutes. So while the roles may appear in here, it may take a little while until they'll show and be available for assignment in the users and group menu. Let's head over there and add a new group assignment. I'm going to take the groups that are already created. Let's take support users and assign the support user role that we just synced from AWS. I'm clicking assign, and I'm going to repeat this also for the network admin group.
And we can assign more than one AWS role to the users and groups in Azure AD.
Yes, of course. Let's do that so we can see how it looks like later on. I'm going to the group selection again. I'm going to pick up the support users group, and I'm going to assign this group with the network admin role as well. I'm going to click assign. Okay.
So when this assignment completed, let's look at the user's experience. Let's open a new browser session and see how user signs in.
Okay. So I'm going to show you the IDP initiated flow, and I'm going to go to myapps.microsoft.com. Signing in with one of my users. And we're going to type in the password. I don't want to stay signed in.
And we can see the Azure AD portal with the applications and AWS accounts assigned to the user.
Right. And as you can see, this user already has assignments for AWS Project A Dev and Project A Prod from previous assignments. And now they also have the new Project B production account. Let's click it. So because we assigned 2 roles for this user group, now we get prompted by AWS role selection menu to choose which role we want to sign in with. I'm going to select the support user role and click sign in. As you can see, we are signing to this account with a support user role with the identity from our IDP, which is J. Jenkins.
We had to go through a number of steps here, and administrator has to do this for each and every new account and to keep managing changes for the account access in both places, AWS and Azure AD. This probably can be automated, correct?
Yes, customers may automate provisioning of new accounts, but managing this configuration and changes may not be the easiest task here.
So what happens when our organization footprint is growing and new accounts being created for new business applications and workloads?
In large companies with more than 50 accounts, they typically create automation to federate their identity provider to each account, obtain role information, assign roles to users in their identity provider, and configure their identity provider to pass the role ARN to IAM. But this can be a challenge for companies with fewer accounts and less sophistication.
Got it. Let's see how these smaller companies can address the multiple account scenarios. For companies with fewer resources to build authorization automation, we don't want to manually configure access control for each and every account. Instead, we'd like to have a tool that allows us to manage a large number of accounts efficiently and to be able to use the same identities to provision the access from one single place.
Yes, an AWS Single Sign On enables us to centrally manage access to AWS accounts and business applications as well. You connect your existing corporate identities and simplify the process of enabling these identities to user resources such as AWS Accounts, also to business applications like Salesforce, Box, and more.
So, what do we need to know about using an AWS SSO?
Hold that thought and let's talk a bit about AWS accounts and how we can manage them. AWS accounts are isolated tenants in AWS. They are shared nothing, zero trust environments.
Can customers organize the accounts for management purposes?
Yes, customers like to put them in some structure that makes sense to, from a business or operational perspective, to manage them efficiently. To help with this, AWS created AWS organizations. With organizations, you can group accounts, for example, by dev, test, prod environments, or by applications or business units. Organizations also enable you to organize these accounts groups into a hierarchy of organizational units called OUs. Typically, these are a standard structure of grouped accounts. For example, you might set up organizational units to contain a development, test, and production account, and then create an OU for each of your projects. Organizations also enables you to apply some policies that govern organizational units by using the hierarchy. This makes it easy to assure compliance using the right guardrails for these accounts. For example, you can specify that organizational units are not allowed to use specific services or products to help you standardize and reduce unwanted expenses. AWS Organizations enables you to do all this together with centrally creating accounts, enforcing audit, monitoring, centrally managing cost, and so on.
Great. So these can help us governing our accounts that federated users can access, right?
That's right, but it also provides a new and easier way to manage access across all your workforce identities, while eliminating a lot of the complexity associated with IAM Federation.
Right. So on that note, let's get back to AWS SSO. To start with AWS SSO, we need to decide what is the identity store we will be using. AWS SSO has its own identity store, and you can provision users and their credentials there if you don't already have a directory. It also supports integration with AWS Managed Active Directory or Microsoft AD on premises. The third option is to integrate it with an external identity provider, such as Azure AD, which we will focus on today. AWS SSO tightly integrates with AWS organizations, and this allows us to manage all organizations' accounts access from this single place, incorporating all accounts in our organization and automate federation and role configuration deployments seamlessly. When we create a new account in the organization structure, or we add an existing account to it, it appears in AWS SSO Management Console, and we can assign users to access it. Let's add some more details how we provision users access to AWS accounts.
Sure. AWS SSO has the concept of permission sets. Permission sets are templates for IAM policies, and they define access assigned to identities accessing to AWS resources and services.
In other words, AWS SSO automates the target account setup using these templates and its integration with AWS organizations, which is very convenient.
Indeed. One last thing that I want to mention before we get into the demos is the ability to configure business applications in the user portal. In addition to accessing AWS accounts, you can configure cloud applications that support SAML. You can select from a large list of pre-integrated applications or use the configuration wizard to configure your own custom SAML application.
Great. Let's see how we enable AWS SSO and prepare the basic setup for it.
We're now logged into the console of our organization's master account. Let's go to the AWS Single Sign On console and enable AWS Single Sign On here.
And this is assuming that AWS organizations already enabled.
Right. If organizations is not enabled, we'll get a prompt to enable it. Okay, that was quite easy to enable AWS SSO. Now, let's look at the configuration for identity sources. By default, we have the AWS SSO internal provider selected. We can change it to Active Directory and select the local Manage Active Directory or AD connector. But note that the directories that show up here are directories that are configured on the same region that we enabled AWS Single Sign On. So make sure you enable it in the right region. Another option, which we're going to show you later on today, is configuring the external identity provider, a simple process of exchanging metadata files. Let's set up some basic settings in our accounts in preparation for the next demo. First, let's create some permission sets.
And remember, permission sets are actually in access policy templates that AWS SSO is going to provision in the corresponding AWS accounts.
Right. So we're going to use the same job function policy as we did before. So we're going to select the support user and create a permission set from it and another one for the network administrator, just like before. Later on, when we're going to assign users, we're going to select the accounts that show up here that are synchronized from our organizations and assign them to specific permission sets.
Can we also have a look how to configure a business application with AWS SSO?
Yes, definitely. Let's go ahead and configure a new application. I can either select an application that are pre-configured in the application catalog or create my own custom SAML 2.0 application. I'm going to configure Dropbox, so I'm going to just select it from the list. I'm going to add the application, and then I'm going to select the configuration instructions that will tell me how to configure my Dropbox setup. This is very convenient because it goes step by step to configure the Dropbox application, and it also populates the right fields so I can just copy and paste them to Dropbox. Let's go to Dropbox. I'm already logged on as an administrator on the settings pane for the single sign-on configuration. I'm going to copy from the guide the identity provider sign-in URL and paste it in here. Next, I'm going to copy the identity provider sign-out URL and also paste it in the right location in Dropbox. Next, I want to download my AWS Single Sign-On certificate. And again, pasting that, or selecting that actually, as my certificate for the federation relationship. Another thing I should do is to copy the SSO sign-in URL so that my configuration will also support the service provider initiated login flow. I'm going to copy that and go down into my application start URL and paste it. Back at Dropbox, I'm going to enable single sign-on. Select optional and save the settings. I'm also going to save the settings in AWS SSO, and my application is configured. When I will configure my users and groups, I can then later assign them in here.
Now that we have seen the basic setup, let's get to the final part of our talk today: integrating with external identity provider.
As you remember, in the very first demo, we showed how to integrate Azure AD with IAM and separately with each AWS account, which in a multi-account environment requires a lot of work, or to create your own automation. Now, let's see how we could simplify this process by using AWS SSO. Let's start from the administrator perspective. In contrast to federating with IAM directly, federating is a one-time setup process with AWS SSO. First, we'll configure SAML. As before, a simple exchange of the metadata files. In place of pulling a list of roles to the IDP, AWS SSO supports the open standard System for Cross-Domain Identity Management, or the SCIM 2.0 protocol, to propagate users, groups, and their metadata from Azure AD to AWS.
Just to clarify here, with SCIM and SAML, users' credentials stay in the identity providers directory, right?
Yes, correct. Now, once we have the users and groups in AWS SSO Identity Store, we can go on to assign access to users to AWS accounts and use permission sets as policy templates for the roles that will be automatically created in the corresponding accounts. And it also creates an identity provider trusting AWS SSO in that account and configures the roles trust policy to trust AWS SSO. We can also go and assign other applications, business applications, to users. So, from a user experience perspective, users sign into the AWS portal and get redirected to the Azure AD IDP for their authentication. Then, when a user selects an AWS account and role for a business or a business application, AWS SSO acts as a federation broker and connects the user to the selected resource.
Good. Let's look how it actually works now.
Sure thing. We're going to the demo.
So now let's configure federation between AWS SSO and Azure AD. First, let's change the identity source for external identity provider. I'm downloading the metadata from AWS SSO, and I'm going to move over to Azure Active Directory. Going to Enterprise Applications, just like before, and creating a new application. For AWS SSO, we're going to select the non-gallery application and give it a descriptive name. This name is not really critical because most of the time you won't see it because we're going to use the SP-initiated flow for AWS SSO. So I'm going into Setup Single Sign On and SAML. And the first thing I'm going to do is to upload the metadata file that I just got from AWS SSO. Let's edit and save. Next, we need to download the Federation metadata XML from Azure AD and give it to AWS Single Sign On to create or to complete the metadata exchange. I'm going back to AWS SSO. I'm taking the Azure AD Federation metadata file and I'm going to finish the setup. Before I can complete the setup, I need to acknowledge that I'm making a change that might affect my users because the existing users in my system are used to sign in with the AWS SSO credentials. So I have to make sure that I'm aware of the changes that I'm going to make here. So let's confirm.
So if I was using the internal AWS SSO identity store, that those users will not be able to log in anymore.
Right. So when we make this change, the metadata or the user context is retained when I change from the internal data store to external identity provider, but the authentication method is now based on SAML. So this is what you're actually confirming here. So AWS SSO is going to take care of everything in the background. And now I can return to continue the setup. So the next part of our configuration is to configure the automated provisioning using the SCIM open standard. This is going to work differently than what we had in the previous demo. In this case, Azure will use the SCIM standard to connect to an endpoint provisioned by AWS and will write all the identities, the users and groups, and their metadata to the AWS SSO metadata store. Let's enable it. So now I have the SCIM endpoint provision for me, and also I have an access token. Let's see how we configure these in Azure. So the next step in here is to go to the provisioning menu item, and again, just like before, change the provisioning mode from manual to automatic. Let's move back to AWS SSO and copy the SCIM endpoint. We need to paste it in the tenant URL box.
And again, we need to remember terminology differences here.
Right. I'll copy the access token and paste it in the secret token box. And then test the connection. Now, you can choose to add a notification email in case the provisioning synchronization process fails, if you want to get notified. But this time I won't configure this. I'm just going to save. Okay. Next, I want to configure mappings because the default set of mappings in the non-gallery application do not match what AWS SSO expects. So I'm going to select synchronize Azure Active Directory users to custom app SSO. And this name here, custom app SSO, may differ in your setup depending on how you set your directory. What we want to do is first to remove some of the configured attributes. And as you can see here, we've got 3 phone numbers. We only need 1. And I'm going to remove the mobile number and also the facsimile telephone number. Another change we want to make here is to change the external ID mapping and change from mail nickname to object ID because mail nickname doesn't create a unique or that is not necessarily a unique attribute. So we're changing it to object ID and confirming. Another change you might want to do is to change the way that mail attribute maps to the email that AWS SSO will get. And if your users are provisioned with Office 365 accounts, then you don't really have to do this change. But because in my account, I don't have any email set up for my users, I want to still relay the email attribute for each and every one of my users. And I'm going to use the user principal name source attribute for that. Again, in your environment, you might not want to do this change.
So AWS SSO needs a unique identifier for the user and an email address to make provisioning working through SCIM, right?
Right. It's mostly important if you have business applications that you want to use because these business applications are looking for the email field in order to map the users.
Understood, but unique ID we need anyway.
Yes. Okay, I'm going to save this. Okay, now before I'm going to enable the provisioning, I also need to assign some users and groups to my enterprise application. So I'm going to users and groups, and I'll click add user. It can be either a user or a group, and I'm going to select a couple of groups here. Project A, Project B, just select them.
And this time, we don't need to assign any roles here because users' metadata will be pushed to AWS SSO, and then we will be assigning permission sets on the AWS SSO side instead.
Correct. So I've assigned my groups here. And now the next step and the final step in Azure would be to enable provisioning. From now on, whenever I want to make any new assignments, I can just go to AWS SSO and make the assignments there. So I'm clicking provisioning status to on. So before that, I want to talk to you about the scope here. So by default, Azure AD only synchronizes users and groups that are assigned to this enterprise application. You can change this behavior and select sync all users and groups, and then even users and groups that are not assigned here will also get synchronized. I'm going to leave it at default and click save. Great. So this is going to take a moment. I'll refresh. Okay, as we can see, we've got our groups and users synced to AWS. Again, just like with IAM Federation, this provisioning happens immediately on the initial sync, but then every 40 minutes it gets synced again. The delta is getting synced again to AWS. In this case, you can also manually set the synchronization state and restart it if you click this checkbox and save it. But now I don't need to do this. So I'm going back to AWS and let's see if our users and groups are already synchronized. Great. As you can see, we have our users and our groups. If I click one of the users, I can see that apart from the username that was synced from Azure, we see attributes like the first name, the last name, and others.
And we can see that these metadata been provisioned by SCIM.
Correct, Yuri. We can also check other attributes that are in the directory, like the user department. Let's assign some of our groups to AWS accounts. So I will now choose a couple of AWS accounts, let's say Project A Prod and Project A Dev, and assign the support user group to have access to these accounts. Next, we're going to choose the permission set. So I want to have a permission set for a support user.
And again, permission sets will be used by AWS SSO to create roles and policies on the corresponding AWS accounts. So now AWS SSO goes to those AWS accounts and creates an identity provider for itself there, and also creates roles with policies according to the permissions templates.
That's right. Now that we have access set up to our accounts, let's also assign some business applications. So I'm going into my Dropbox application that we configured earlier, and I'm going to assign the same group for support users to get access to Dropbox.
Awesome. So when all this is ready and all assignment is complete, can we jump to the user's experience?
Yes, definitely. We have to copy the user portal URL and hand it to our users. We can also customize this URL so that it will have a familiar name that user recognizes. I'm going to use the default. Let's move in to a new browser and paste this URL. We will now be taken to authenticate with our Azure AD Identity Provider. Let's use JDO. And now that we're authenticated, we're getting to the AWS SSO portal.
And we can see the accounts and the business applications that you just assigned to the users groups.
Correct. So if I'm going to Project A Dev, for example, I can see that I have the permission set for support users provisioned for me. I'm going to click the management console and single sign on into this account.
Let's quickly see the IAM configuration on this account. What did AWS SSO provision for us there?
Yes, of course. Let's go into the IAM console and see the identity provider first. So as you see, I have a new identity provider here that was automatically created by AWS SSO. I also have the role configured for me based on the template of the permission set.
And we can see the support user role here.
Right.
Can we also have a look how user logs into the business application via AWS SSO?
Yes, of course. So I'm going to click the Dropbox business application, and I'm going to be redirected now to my Dropbox account. I'm going to confirm that I want to single sign on for Jane Doe. And now I'm logged on as Jane Doe to the Dropbox business application. And this can be any application, either one of the applications in the list or any custom SAML application.
Amazing. And Jane Doe carries identity that actually the source for this identity is Azure AD, metadata being provisioned in AWS SSO, and then we single sign on using this identity to the business application. This is great for human accessing AWS resources via the console. Let's have a look at a new AWS CLI feature for AWS SSO.
Yes, with the new AWS CLI version 2, you can get temporary credentials for accessing your AWS accounts and resources from the command line.
Let's try it.
So for this final demo, we're going to show you how to use AWS CLI version 2 to integrate with AWS Single Sign On. So I'm going to type in AWS 2 for CLI version 2, configure SSO. And the first thing it's going to ask me is to paste the SSO start URL. If you remember, we used this URL to access the SSO portal previously. So I'm going to paste it here, and make sure you paste the entire URL, including the /start at the end, otherwise this won't work. The next thing I have to specify is the region where AWS SSO is enabled. I'm going to select US East 1. The next thing that is going to happen after I'm going to press enter is that AWS SSO will open a browser window and take me to the IDP to sign in. Let's do that. I'm going to sign in with my user Jane Doe. And I'm going to be redirected back with my SAML assertion to single sign on and to authorize the AWS CLI session. I'm going to click that. And now back in my AWS CLI, I can see that I have the role selection menu where I can pick the role and account combination. It will allow me to create a CLI profile for that specific role. I need to specify the default region for this profile. Basically, same as you would have set up for a regular credential configuration setup. I'm going to use USIST 1 here as well. And AWS CLI will create a new profile for me with the prefix of the role name and the suffix of the account number. And I can use this profile to specify which permission set I want to use when I will log into AWS SSO now. So the next thing I want to do is to use AWS CLI version 2 with this AWS profile. So let's call the STS endpoint and get our identity. And I'm going to copy the profile name and paste it over here. As you can see, I'm logged in or assumed with that role that AWS SSO created for me, and the identity comes from the IDP.
This is great. Also, you use the browser to provide your credentials for Azure AD and to authorize your session. What happens if you are in the environment where a browser is not available?
When you log in, AWS CLI generates a one-time token, which you can manually enter with the browser in a different environment and register that session.
Awesome, great feature. So I can type it, for example, in my laptop and to authorize my session that way. So let's recap. At the beginning, we showed how to integrate an external identity provider, such as Azure AD, with AWS IAM for each and every AWS account. As far as you could see, it may become quite difficult to manage access control to these accounts, and it requires to write automation when your organization grows. AWS SSO natively integrates with AWS organizations and helps addressing this challenge. It allows to provision and manage access to your accounts and business applications from one single place for both AWS Console and AWS CLI. While AWS SSO supports its local identity store and integrates with Microsoft Active Directory, either AWS Manage or on-prem, it now also integrates with an external identity provider, such as Azure AD. We have demonstrated how this enables you to keep managing existing users' identities and provide access to AWS accounts and business applications within minimal configurations on AWS side. That is done at one single place. All this using industry standard protocols like SAML and SCIM.
To learn more about what we discussed today, please check these links.
It's been a great session. Thank you, Lior. We have some time left, so let's take some questions.